Good morning, everyone. Welcome to the first day one of the HPC onboarding course. Thank you for your feedback and participation yesterday for the Unix course. I hope you had a great day yesterday. And today, day one, we will start the HPC intro. The commands you learned yesterday will be handy today. So your instructor is sharing the collaborative document which we use for Q&A. You got an email about it, and I have pasted this on the Zoom chat. Please remember that we take all questions on this Q&A and not on Zoom chat. Please use it interactively, and please ask a lot of questions during the workshop. We are here to answer you and assist you there. Two important things. One, as you can see that I'm recording this event. So please feel free to switch off your cameras if you don't want to be recognizable. We will edit this session and publish later this week, and you will get a notification and summary of this course when we publish these videos. And the second important thing is that we follow the Carpentries Code of Conduct. That means being respectful, being friendly, use respectful language while you type on Q&A. And please don't try to give any sensitive information on this collaborative document, since this is a recording and it will be recorded, and when we publish it, it will be seen on this video. So please don't use the sensitive information. And just like yesterday, we have an icebreaker question. Sabri, can you move a little bit down? And there is one question for you to answer. Have you experienced any computational analysis task that was too big for too long for your laptop or desktop? Please elaborate. That how to edit the collaborative document, as you have seen yesterday. On the top of this page, press the pencil icon and edit it. And ask your questions below. We will be here to answer, and it's not only me. All our training and staff will be there. And just like yesterday, you will have many instructors. You have met Sabri. You have seen Sabri yesterday. There will be more. Today you will learn what is a cluster, why we should use, and there will be an exercise how to submit jobs on the cluster, and the final session will be transferring files between your laptop and the remote cluster. We will have 2 breaks, better than yesterday, 15 minutes break. We will try to keep it as it is. There will be this one exercise session. You will have enough time to do submit a job on the cluster saga. And all this Q&A from yesterday is linked on this collaborative document. You can, and it is published, and you can revisit it if you want. And please ask a lot of questions and be interactive as much as possible. And without much delay, I will hand over this Zoom dais to Sabri and Morten, who is going to teach this first session. Sabri and Morten, would you like to introduce yourself first?
Yes, my name is Sabri. I'm joining from Oslo. Before I start, I would recommend that everybody to switch off the camera, just because it's easier for the post-processing of the video. I'm also involved in the training team at Enbris, and also in the Norwegian AI Cloud. Yeah, Morten.
Hello, everyone. Good morning. My name is Morten. I'm joining also from Oslo. I'm at the chemistry building. I'm a trained physicist, but now helping out with the Enbris training.
Yes, Morten. So if you ever get lost where you are in the course, I would recommend your landing page should be bookmarked as this shared document. And Daniel has also shared this on the chat, and time to time people will paste this link as well. So if you get lost, come here, And the training material that I'm going to follow today is from the link from the event page. So if you go to the event page, I'll close the other tabs. You will see that we have gone through some lessons yesterday regarding the basics of Unix that we need to start using HPC. So I would imagine you are comfortable with commands like SSH. So because that's a requirement for today that you should know and it works. Otherwise, please mention that in the shared document itself, and then we can have a look. And in the morning, what we are going to do is motivate ourselves, why we need to go through this HPC learning, and then we'll see some very basics of getting started. So while we start this, as Dania mentioned, so we have this shared document. And in the shared document, if you're on a full screen, you will see your pencil icon on to the left, maybe. Because I have a smaller window, my icon is here. So if you click the pencil icon, you can edit that. So under this, so we have a question here. Have you experienced that your laptop or your desktop that you have at your disposal at work was not enough? Was there any need for HPC? So that's very important to know before you start learning. But I see that people are typing in. So keep on typing in your answers. And if you don't see this view, the trick is to find the pencil icon on this document. And on the first part, we will start, Morten and I. We will discuss a little bit on using the cluster. Let's see. Let me switch off some of the notifications. Yeah. So from the shared document, I clicked on event page. From the event page, I found the why use the cluster, the first lesson, and then I'm here. And in this lesson, we are kind of stepping back a little bit and see why someone would be interested in high performance computing. And then we'll be able to describe a little bit of the HPC systems, not the whole technical requirements and or how it is connected and etc. But you need some sort of understanding, basics like it's not one computer, but a collection of computers working together. And then we have, we are going to kind of discuss a little bit about this paradigm shift kind of thing that we're going to experience when we move from our laptops, which means that something in front of you, you type something, it gets executed and you see the results in front of you, to a system that is not in front of you, maybe across the internet or far away in another city. That's something happening, and then you have to instruct that computer to do something for you and then get the results back. So that might be a little different for people who are just getting started. So the research problems, when we, not all research, but some research problems, they have to handle larger data, large number of iterations. So when this, when you face this situation, you might need something bigger. So Morten, from your research experience, can you give me some examples, or maybe one example of elaboration on what this what this is, what we are asking, and kind of expected answer?
Yeah, I can give an answer from my own life. So during my PhD, I was running a lot of simulations. I was running molecular dynamics simulations, and in principle, each one I could run on my laptop, and it would take maybe an hour. However, I needed to make a single figure in my PhD thesis. I needed to run 5,000 of them. So in order to finish my PhD on time, I instead ran them on the Betsy cluster, and there they took 5 minutes each and I could run 5,000 in parallel. So I can make my figure in a day instead of having to wait for my laptop for 3 months.
So how long did your PhD take?
Shorter than if I had done it on my laptop only.
Yes.
So how about
Good
you?
that-
Do you have any real life experience? working on a
Yeah,
customer?
so my experience comes with you know, as you said, the word that you mentioned, the parallel, that's very paramount to what we are learning, which means that the HPC system, if you take the clock, you know, if you take the number of calculations it can do, as a single computer, it's not more faster than your laptop. As a single computer, it's not fast. But the trick is that you recruit so many computers, do so many things in parallel, which means that you have your big problem, you break it into smaller pieces and delegate it to different computers so they can do it together. So in your case, the 500, the whatever iterations that you had, and in my case, I had a big data file that I had to process. We are talking about billions of lines. Now, if I had to process line by line, it will take 1 billion. Like if you think of a loop, you know, go by one. But if I can divide that into 1 million chunks, then it becomes less iterations that you have to do. So let's see what people are answering as well without taking too much time. Okay, so yeah, so sometimes it takes days. So another thing, Morten, that you might have also experienced is that when you have to do this analysis, which take a long time, you might not be able to keep your laptop on for a long time, which means that you don't have to sit in front. So you have to think of a system and a way of working that your analysis do not need your presence in front of the computer. So that's also when you think about batch submissions and similar scenarios later on, we have to think about that as well. Do you want to go through some of these, Morten? Some answers?
I think we can just comment on the first one maybe, because it raises an interesting point about memory. Whereas the laptop that I'm sitting on right now has, I think, 16 gigabytes of memory. And if you need to run some big analysis, then this might be totally inadequate. So you might need some bigger system.
Do you think, let's say in the example I mentioned, that this 1 billion line file, if I had to load, you know, the entire file to the RAM, even the, you know, we have several types of nodes we'll talk about. Some nodes have a lot of memory, but even that memory, the ability to break your problem down, even if it needs a lot of memory, do you think it's a better investment that, you know, you try to, although you have a lot of memory at your disposal, maybe for scalability you try to kind of break your problem? Do you see a benefit in that model?
Yes, of course. I mean, it's not probably in your case. It's probably not helpful to load the entire file into memory and then try to work with it. But some problems are irreducible into smaller chunks. I mean, some problems are just inherently hard and require a lot of memory. So there's not always something that you can do.
Yeah. So all these are, you know, bioinformatics analysis, simulations. Yeah, email related tasks. So you might have models, you know, number of parameters might, you know, if you want to do it on a single computer, it might take a long time. It might not be even possible. And I also want to note down the second important word, Morten, that you mentioned, which is reduce. So the first one was parallel. So let's come to those a little later. So we will include what you have included in our lesson. So we'll take a summary of what you typed, because all these are very relevant, because this course is about practicality. This course is not about passing an exam, but to take home something, you know, relevant for your work. So I see that, you know, all these are very relevant answers. Then I think we are more or less motivated that, you know, we should, you know, use HPC. We have a need for HPC. The overall structure, the technical makeup of it. We don't go for much detail, but I would like to say something about, some terms that we might use later. So on your laptop, when I say laptop, it might be a desktop. So most people use laptop these days. That's why the word laptop comes in. So you have a keyboard, you enter something, and there's a memory that loads the data, or the parameters or the variables that need for the analysis. And then you have the processing unit that will process. After the processing, you get your results on your display or in a file, or an image file or a text file in front of you. So you just directly get it. But sometimes when tasks become too big. So in this example, they're talking about an example where you want to show the shortest path, which means that you have a lot of possibilities, nodes, we call it. Let's say if you think simply, if you want to go from one place to another, the different routes you could take. So this might not be possible to analyze on a mobile phone or a laptop, for example. So then what we do is we hire a computer not near you. So these computers are big. You don't want to carry them around. So we fix them in a central room, and usually you connect it via the internet to perform the analysis. So still, this is one unit. And then when you come to the HPC system, is that these computers, these servers that we're talking about, more powerful computers, more processing power, more memory, connected somewhere far away in a room. We connect many of them together. So they can work as a single unit. So the trick relies on the two words that you mentioned, the parallel processing and reducing, kind of ability to break your problem down into smaller pieces, so each of these can analyze. Let me see whether I have a video. So this is how it sees. You see the HPC system. So this is our old cluster, the Arbor, which is now decommissioned. So it's a collection of pizza boxes connected with cables. So you don't find a keyboard or a screen display to see anything directly. So you have to connect it through the internet. Any other explanation that description, Morten, you have for this?
No, just two comments. Maiken, I think, had a comment earlier.
Yeah, it was just, for newcomers, it might be weird that one uses the word high performance computing. Maybe it's obvious for everyone, but and you've touched upon it, but why do we call these systems high performance computers or HPCs?
Mm-hmm. Why do you call that, Micah? Do you have an answer for that?
Yeah. Well,
please.
Typically these computers perform. They're quicker, have more memory, they're faster with the connection between the nodes than your normal laptop. I guess that's why it's called high performance computers. But yeah, it's also interesting if somebody knows the history of the word or the term, but maybe nobody knows, and that's okay.
It's also a bit of a paradox because, like, machine for machine, if you look at one single CPU
exactly
inside the server, what you are currently working on, if you are watching this from a new fancy laptop, each CPU in your laptop is probably faster than each one of the CPUs on the server.
Yeah.
However, when you leverage thousands of CPUs together with a very fast interconnect, so they can talk to each other very quickly, then you can use this divide and conquer strategy that Sabri talked about, where you take a big problem, divide it into smaller chunks, and then you find a way to solve each of the smaller chunks very, very fast at the same time. So
and I guess the connectivity between each of these computers is the essence in the high performance computing systems, which makes it stand out compared to, if you just connect a couple of laptops together. or many laptops together.
Thank you, Maiken, for that description. So two things, in addition, that I think it's a good way to like, if you can't comprehend what this brings out, please like think a little bit of what Maiken said, about connectivity, and what Morten said. Your laptop might be faster, but we are talking about many computers working together. So there are two things that we already mentioned a little bit, is that we need to understand the command line interface. There are ways to use graphical user interface as well, but for the course, this course, and also we also recommend that you learn a little bit command line interface to interact with cluster. And rather than like a single machine that has a direct keyboard and a monitor in front of it, we are going to talk about something, some many computers connected together that we are talk across the network. There's some history and some details about how fast the computers are. Morten, do you know what's the position of Betsy and maybe even Lumi?
Yes, because I actually looked it up yesterday. So so Lumi, there's this top 500 list, which is published every few months, supporting the highest performing computers in the world. And currently Lumi in Finland, which you might have access to, is sitting at number 5 on the list. So it's the 5th biggest, fastest supercomputer in the world. And currently Betsy is number 161.
Okay. So we are talking about like supercomputers here. So 161 means still it's very powerful. So you could read more about these details here, and also if somebody could place the link where we describe how many cores and how many teraflops our systems are. So we have some description there. We could place that on the shared document. So without taking too much time, because we need to take something, do something hands-on. So there are a few things that we have to kind of summarize. All computers located are in the same location. So most, not most, like always the HPC system, they are mostly in like a single room or a single building, because network cables can, they can't go very far if you want very fast connection. Then what happens is they have identical architecture, which means that if you compile something on one computer, that could run without any problem in all the other computers, which means they have identical operating systems, identical set of libraries, identical set of software, and they have shared access to a storage, which means that if you log into one machine and place a file, all the other machines will see the file in the same way. So there's no refactoring needed if you want to run another machine. So it's identical setup. And the clock frequency is set like the same clock time is set on all computers as well. So there are some analysis which needs the synchronization of the clock. So then what happens is the clock on one computer is set identical to all the other computers. And then there's a scheduler involved. That's the next lesson, which we'll talk about a little later. So these things are kind of different than you are booking a VM on a cloud system. But also cloud systems like Azure and Google, they also have HPC systems behind their VM. So that's another thing. But if you book one VM,
can you explain what a VM is?
So VM is a virtual machine. So like when you log into one computer, you SSH and you land on that computer. So instead of going to a physical computer, you could have a virtual, like a software that pretend that it's a computer. So you can run multiple pretend computers on real computers. So then the resources could be better shared. So you connect to those things, and then you work on. So so just because you connect to a Google VM, it doesn't mean that it's fast. No, it's not going to make your work fast. Or even using the HPC system itself, it's not going to make you fast unless you adapt your work to that. So these are kind of summaries that you could think of. So we'll go to the next lesson. Morten, is that okay?
Yeah, let me just, I can take over the sharing. So hopefully this is showing okay. So now, after having motivated ourselves as to why we should use the cluster, we now dip our toes in the water, and then we will start getting into actually how to log in and how to use the clusters. So before I start, this is an interactive session, and at least for the first part, I want mostly everyone to follow along, and I will follow this this document pretty closely. So this should be linked in the collaborative document, or you can find it on the course page. So the very first part about the getting user access and access to a project, I think everyone should have already done. And if you haven't, I think it's a bit too late. But if you don't have access, you should contact Dania. And we can you can do that in the Zoom chat, I think. But now, having learned about the clusters and the HPC systems, the first step of using the HPC systems is to log in. So here in diagram form, we are sitting on a laptop. We want to connect through the internet to a cluster. And when we connect to the cluster, we will connect to this blue part of the cluster, which is the login node, which I will explain more in detail later. So the cluster that we are sitting on, maybe Sabri, you mentioned in the last lecture that this is a machine that is sitting physically in a room somewhere. So we are working on the Saga cluster. So can you say where this machine is located?
Did you ask where it's located, Morten?
Yes.
Good question. It's in Trondheim.
Is it? I don't actually know.
Yeah. It's in Trondheim. Yes.
Okay, so it's
Yes.
in a basement in Trondheim somewhere. But the beautiful thing is we don't need to know where it is to use it. So yesterday morning, Björn showed you all SSH, so secure shell, how to log into a remote machine. And we will repeat a bit the steps that Björn showed you yesterday. So the first thing that I want everyone else to do is to go to a terminal and verify that you have SSH installed. So here in my terminal, I will write SSH dash and a capital V. And once you press enter, it will show you something. The version doesn't really matter, just as long as you have SSH installed so that you can log into the cluster. So please, everyone, open your terminal and do the steps under if SSH is installed. And if you have problems with this, please ask in the collaborative document. I will give everyone just a minute to verify.
So while people verify that, what is this SSH, Morten? What does it do?
So Björn talked about this very briefly yesterday morning. So SSH is the secure shell. So it is a way to establish a encrypted connection to another computer, so that we can log into it and do operations on it.
Without everybody being able to see what you're doing.
Yes, that's the key point with the encrypted. So if you are doing highly secret stuff or anything that you don't want anyone else to know about, then it should be safe.
Shall you have a poll on the HackMD to see how many people got the SSH correct?
Yes,
Or
hopefully
how many people they have
someone
access?
has,
Yes.
yeah.
So when you test this, and if you see a version, so it doesn't have to be what Morten's version, it has to be some version when it is ready. So would this work on Windows as well, Morten? Or is it has to be Unix computer?
I am by no means an expert, but yes, it will work on Windows. And I think if you have a modern Windows version, you're using this subshell for Linux thing, where it should look more or less like it looks on my screen.
Yeah, so in new means like if you're past Windows 97, your computer should have SSH. And if you're still on Windows 3.1, for example, then no chance.
Yeah. Okay, so let's move on. Hopefully everyone has SSH installed and it's working. If you don't, please ask a question in the shared document, and the other instructors will hopefully help. So now the very first step in working on HPC systems is being able to log in. So how you log in is you use the SSH command. You type SSH, your username. So this will be different for you than it's for me. This is my username. And then for this tutorial, we will be using the Saga system. So the address, the SSH address for Saga that we would log into is saga.sigma2.no. And then when you hit enter, if you have never logged in before, you will get a screen that looks like this, where it says, you have never logged into the system before. Do you trust this system? And it gives you a fingerprint of what is called a public key, saying this is, you tried to log in with an encrypted connection to the system. It responds with this key. Do you trust this? So now if you want to, you can go to the Sigma2 documentation, and then you can find the official fingerprints of all the systems that Sigma2 manage. Because this could, in theory, be someone else pretending to be Saga. So if you want to be absolutely sure and verify, then you can take this key, and hopefully one of my co-instructors can post this the URL to this web page in the shared document. You can go to a source which you trust, and you can copy the key that should be Saga, and you can paste it into your terminal, and it will check that the key that Saga sigma2.no returned is in fact the key that it should be, so that you are logging into the correct system. If you do that, it will say it has permanently added this address to your known host, so that the next time you do this, you will know that you are logging into the correct server. Afterwards, it will ask for your password, while you type your password, it will not show you anything on the terminal. So I have now typed in my password, but it's still showing as blank. This is for security reasons, so no one can peek across your shoulder and look at your password. You hit enter. That's weird.
So Morten, if you take a little too long from SSH until you type the password, it might get disconnected. And also, yeah, this time I think the password is wrong.
Okay, we managed to type our password correctly.
Yes, so when you type SSH, it starts connecting. So then there's a timeout. Like if you don't type the password in a seconds, then it might disconnect. So that might have happened for you.
Okay, so don't do what I did, where I typed the SSH command and then waited for 2 minutes. So maybe we can have a poll also in the HackMD to check if people have managed to log into Saga, because this is also a step that I need everyone to follow along.
So Morten, there might be users who have accounts on other systems like From, or even if someone may be following on Fox as well. But for this course, the course organizers, Dania and others, they have set up a reservation, which means that you get priority when you test things. So Saga is the place that you'll have access to this priority and to use your course account. So if you have other accounts on other systems, please by all means do that. You could use that. But for the course, we recommend using Saga. Is that correct, Morten?
Yes. So all of the steps that we're doing should, in principle, also work on the other clusters. But it is if you use Saga, then you are guaranteed that it will work. So it looks like in the share document, everyone has managed to connect. I will just give you guys 30 seconds more.
Yes, Morten, because we have 45 participants, I would also say that maybe some people, they don't try to SSH because they're just following it on. So I would recommend we could also include that, I'm not trying option. So that's okay, because we just want to have the number yes should be close to 40 something. So that's to make sure that we don't count the people who do not try. I will include that option as well.
Yes, okay. I think we are ready to move on. It seems to be working for most people. So now if you look at my terminal from before, it said my username at my laptop. It has now changed. And for you, it will look similar or the same. So now it says my username at login4.saga. So now come to the next question. Where are we? So now we have logged into Saga. And as Sabri told you last lesson, Saga is not one big machine. It is a collection of many, many, many smaller machines. And on the picture I showed you earlier, we are now in this blue box, which I call the login node. So the login node is where you land when you log in. And there are 5 different login nodes on Saga. you can check which login node you are by typing the command host name. When you type this host name, it will give you the name of the login node that you landed on. So in my case, this is the 4th login node, but this is automatically load balanced. So if the 4th login node is very busy, then you will probably land on a different one, for example, 1 or 2 or 3 or 5. But these login nodes, they act the same. Most of the time, you don't have to care which login node you are in, but you have to care that you are in a login node. So the login node is not meant to be used to run big calculations, because the login node is shared between everyone using the cluster. So if you run some big simulation or some big operation on the login node, you might hamper everyone else working on the system because they can't properly use the login node. The login node is meant to be used to organize and start the jobs, not to run the jobs themselves. And we'll get back into what the jobs are and how to schedule them later today. So the directory that you land in when you log in, if you write pwd, print working directory, it will tell you that your home folder is /cluster/home and then your username. And if you have never logged into Saga before or any of the Sigma 2 machines, then you will not have, this will be mostly empty. So remember from yesterday, Maiken told you about this ls command, ls lha. So we can see what is in our home folder. So for me, I've been using Saga a lot. So I have lots of different stuff here. When you do this, yours might be empty. But this is your home folder. So Sabri, maybe you can comment on the home folder and how files work on Saga. So when I run jobs, do I have to copy all my data around? If I install a software in my home folder, where can I access it from?
So this home folder, when you type pwd, you show that it's under cluster. So everything under cluster is accessible for all the compute nodes. So in fact, one recommended way that you could use install pip packages, for example, that you usually install in your home directories, is that you can install them before the job starts. So if you have a pip package, if you install numpy on your home directory, that numpy will be available for all the compute nodes. In further down the document, maybe there is some diagram which shows this connection later on.
Yes, we come to it at the end. Okay, we will get back to it.
Yeah.
So as I said, the Saga, the HPC system is not one huge machine. It is a collection of many smaller machines. And each one, as Sabri showed you before, it is made up of these, he called it pizza boxes. They are small blades in the server racks, which he showed you on the video. And each one has a name, and each one can be used to run calculations. So here again in diagram form, I am sitting on my laptop. I have now connected through the internet to the login node. If you type again host name, I am sitting on the 4th login node on Saga. So that is this blue box. And now through the login node, I can start jobs and run operations on the compute nodes. So in order to see the compute nodes, we can run this command sinfo. So let's do that. And I have to scroll up because there's a lot of information. So sinfo gives information about all the available smaller machines on Saga right now. So if you see, there are lots of partitions. So these are chunks of the machine. They have different names. They have different uses. So the normal partitions, they are nodes. Usually they have 40 CPUs each and around 200 gigabytes of RAM. And you can see the state of each of them. So draining, I think, means it has been reserved for something, and it's trying to stop. It's stopping waiting for jobs running on it to end. Mix means it's some of it's running, some is waiting. Idle means it's available for starting jobs, but not currently running. And in addition to the normal partitions, there are also other special special parts of the Saga machine. So you have some called big mem, which is these are machines with very large amount of memory. You have even bigger if you need really a lot of memory for your job. If you have some problem which you cannot subdivide into smaller chunks, you really need huge amounts of memory, then you can use these. We have the acceleration nodes, which are contain GPUs. So these contain NVIDIA P100 GPUs. You have some others. I'm actually not sure what Optimist is. Maybe somebody.
Yeah, so some nodes, so some jobs you could start. They will, like if somebody else asks the computer, they will give away, which means that if your job is capable of starting and stopping many times and still get completed, you can ask the Optimist queue. These computers, but you should plan your work that it could start and stop many times, which we call this checkpointing. So if you know what that is, you could use it. So and Morten, I think we should wrap it up within 10 minutes. So maybe you could plan accordingly.
Yeah. Okay, thank you, Sabri. So moving on, I think it's useful to explore a bit. So this part, you don't have to follow along at home, as we say. But it will be more or less me exploring. So as I said before, each single CPU on the cluster is not necessarily more powerful than the CPU that you are working on right now in your laptop. But the power comes from having many of them. So for a minute, let me log out from Saga and I get back to my own machine. So let's see here what I am working on currently. So if I type nprompt, it tells me I have 12 available CPUs on this machine right now. And I can write 3, and it will tell me I have in total 16 gigabytes of memory available. So this is a fairly okay laptop, but not stellar. I can run simulations on this, but if I want to run super huge simulations, it will be slow. So let's log back into Saga, and then we can explore what are the resources available on Saga. So once again, notice before I landed on the fourth login node, now I landed on the second one. As I said, these are automatically load balanced. So right now, login 2 is less busy, so it puts me on the second login node. So let's see what we have available here. So the login node, as I said, should not be used for running heavy calculations, but still it is moderately high amount of the CPUs. We have 64 CPUs available. We have a lot of memory actually available. But the real power in the machine, if we go back to S-info, lies in the compute nodes. So let's log into one of the compute nodes and see what we have there. So these all have names. If you try to do this, you will be told that you are not allowed to do this. This is because I have admin access and you don't. So there's no need to try to follow along. Just look at what I'm typing. So here we can once again say nproc, and this will say we have 80 CPUs available. So this is for one of the compute nodes that you can reserve for your jobs, which we will talk
By the
about.
way, Morten, if you have a job that is submitted, we'll talk a little later. Anybody could do what you're doing if they have a
Yes,
job running.
but you need to have a job running
Job,
on
yes.
this
Yeah.
on this node currently. So I think this is I think these are 40 physical cores and then 80. So there's some these are some fancy cores, some hyper threading, something. So it looks like 80 CPUs.
So you have actually two CPUs, and each of them have 20 cores, if I remember correctly. So it's your laptops usually have one. So on Saga, we have two CPUs on the motherboard, as in the diagram.
So if we compare this to my laptop now, even just one node on Saga has 80 CPUs, whereas my laptop has 16. And it has 170 gigabytes of RAM, whereas my laptop has 16. So you can see each of the nodes are already very powerful. And when you consider that you can string together multiple of the nodes and run simulations on more than one node at the same time, you start to get a feeling for how powerful this can be in terms of running simulations. So let's log out from this C521 node. We can maybe also try to see what's going on one of the GPU nodes. So let's do this C71. So this is one of the Excel partitions. So this is one of the GPU nodes. If we type nproc, we will see this has 48 CPUs, which are used just to handle and organize mostly the GPU workload. And we can do NVIDIA SMI will give us information about well, actually, let's do like this. So this will give you information about the GPUs. So these are P100 cards. There are 4 of them in each of the nodes. They are currently working. So this we have basically gone through. So now we get back to what we talked about just before. So maybe you want to say something about this diagram summary.
Yes, so this green disk that we are shown, which is called the cluster file system, which actually uses a specific special file system management systems like BGFS and Lustre. You could there's more detail about it in the websites if you want to read. So these file systems are very fast, and they could be accessed by many computers, and they are also designed that multiple threads can operate on files. So this file locking is very little advanced, and they are very good at handling large files as well, but they are not that good at handling very large number of small files. So if you have 50 million small files, they are not good. But if you have a 2 terabyte single file, they are very good for that. So there are advantages and disadvantages when using parallel file systems, that you should not have a lot of files lying around. You should have them as an archive if possible. But the basic idea is that if you place a file on one system, for example, from the login node, that will be available for all the other compute nodes in a very fast way. Morten, I think we are out of time now. Maybe you want to summarize a little bit?
Yes, I think we have 1 minute maybe. So in summary, this is we have just dipped our toes in the water for a bit. We logged into the system, and then we explored the system just a bit. And I guess a few key take-home messages is, when you log into any of the HPC systems, you will land on the login node, and just be careful to not run big time-consuming commands on the login node, because you are cluttering up the login node for everyone else, because they are also using the same login node. So actual jobs, which we will learn about very shortly, are run on the compute nodes. And we have just shown that the compute nodes are very powerful. So you can run big simulations, and you can run them very fast. So that's, I think.
Yes, Morten, I think, thank you. That was a very good explanation. So some most questions are in general in the HackMD, in the shared document. So I don't see anything that very specifically that everything is answered properly. Regarding the power consumption, so these laptops these days, they are very good at switching on and switching off. So when you have a high load, you have multiple cores starting up, and then some of them are off. So you could not compare power consumption with your laptop and the HPC. So the power consumption is a lot, because they always run. And there are certain Slurm, like the one we're going to talk a little later, you can shut off and shut down, but you should imagine that all computers are running all the time. So environmental wise, that is the cost. Danya, I think maybe you could announce the break now, and then 10 minutes we can join after 10 minutes.
Yes, Sabri, thank you, Morten and Sabri.
Sorry, Tanya, do you also want to take over the sharing? Maybe
No, maybe Sabri can take over since he is
Okay.
going to share it. Thank you so much. That was an interesting interactive sessions. And we will have a 15 minutes break. Just want to announce that we will archive this collaborative document like yesterday, and we will share it publicly after this event. So you can come back and see this. Revisit. Thanks. Okay, we will come back after 15 past 10, Sabri.
10 past, is it 10 minutes?
No, it is 15 minutes
15
break.
minutes? Okay, yeah, okay.
So we are back from break then.
We should be, yes, I'm back.
Yes, so you will have a new co-instructor joining Sabri to schedule jobs on Saga. Buket, would you like to introduce yourself?
Thank you, Danya. Hi, I'm Buket, working with Sabri in University of Oslo in the IT department. I'm also working in Norwegian AI Cloud project. Yeah, so today I will be with Sabri on scheduling jobs session. You are muted, Sabri.
Yes, thank you, Bhuket. So we are going to follow this lesson, scheduling jobs, and I'm going to open that one. And Bhuket, you should make sure that I don't go beyond this time, so people have enough time for the exercises. So you should stop me.
Okay.
Yes. So the scheduler is something very unique when it comes to your transformation from your laptop or a computer that has direct interaction with a commonly shared resource. So your negotiations, your transactions with the HPC system is always through the scheduler. And then we will see how to run a small, we call this hello world example, which means that it's a very basics. So we are not going to run a big analysis. We're just going to show you how you get started. Later on, as the course progresses, and also in our advanced course, you can learn more. And if you're already familiar with this, and if you already submitted a job, then it might be a little boring for you. But you might also help out in the shared document answering the questions. And then Bhuket, we come here now. So imagine that you want to go for a restaurant to dine with your family and the two kids. You might make a reservation at the restaurant. What does making a reservation means for you? What does it mean?
Well, this means I'll come at that time with this many people, and we want to stay as this as, for example, 1 hour. Yeah, we need to do this in order not to wait at the queue.
Yes. So how does that help the hotel manager or the staff?
So they can organize their resources, maybe tables. Yeah.
Yeah. So exactly that's how it works in the HP system as well. There are many computers and many users. So we have to find a way that the computers and the users they get the users they get to use the computers in a fair way. So instead of a person who's deciding who runs the job first, we have a piece of software that is the queue manager in the blue here. So so we use that software in order to manage these jobs. And people, they will come with their jobs and they will queue up. So if the restaurant is so popular, the queue will be longer. And if you don't want to wait in the queue, you can make a reservation in advance, like as Booker did, and then they can just directly go in. Regardless of how this you go into the restaurant, when you go inside the restaurant, you will find tables. In our HPC systems, you will find compute nodes. So some compute modes, as described here, they might be idle. Morten showed that in his info. Some computers, they are waiting for you to come and analyze your job. So the scheduler, it will send people directly to idle computers. And then you will have one compute. If you take a one compute node, Morten also showed that there are many cores, so people would share it. So unless you get asked for exclusive access, you should imagine that you are not the only person who's performing in that computer. So it could be shared, but data security is managed in a way that unless you specify that your data should be shared, nobody else can see your analysis. And then you will have busy compute nodes. So this one, for example, it's booked, so it will say allocated. So the queue manager should not send people here because it's busy. And then we have mixed compute nodes. Some things, some computers might be busy. In a computer, some course, part of the course might be busy and part of the course might be available for others. So the reservation, so when you make a reservation in advance for the course that we are going to do today, the today's course, for example, then you don't have to wait in the queue. You can directly go to that table, but you can only dine in that table with that account. And in addition, there were some drained nodes that Morten showed before. They are being prepared for something else. So those tables could not be used as well. Is there anything else you want to mention in this diagram, Bogart?
No, thank you.
Good. So this queue manager or the scheduler for our HPC systems is called Slurm. So that is the software we use for all the HPC systems that we have in Norway, the main NRIS managed systems, and also on the Lumi supercomputer, it's Slurm. So let's see how we go about negotiating with this scheduler or the Slurm. For this, what we're going to do is to run a very small job or a small analysis to check. So from my laptop, I'm going to go to Saga. So I'm going to ask Saga. So I'm on the login node. And to make things to a little bit organized, Mike and others, they showed some commands yesterday. I'm going to create a folder with today's date. So I can, if I logged out for some reason, I can get back this to here more easily. Right. So I'm in a folder. So then I'm going to create a file with the text editor Nano that we learned yesterday. Example job.sh. So it'll open in a window like this. And we don't have a graphical overview of this. So this is it's called terminal editor. What we type and what we see is what the computer sees. But if you open a Word document, for example, there's a lot of metadata. So if you have bold text and so many modifications, what you see and the computer understands are different. So you have to use plain text editor for this. So first line is the shebang line, which says that this is a bash. This file is written in bash language, or rather, the content of this file should be interpreted in bash. So you could write job scripts in Python and any other languages, many other languages, but here we are using bash. Then I'm going to echo. We used this command yesterday without printing a new line with a -n. This script is running on, and then print the host name. Okay, so this is the content of the file. I'm going to save it Control O. If you remember with this the shortcuts that we had yesterday, it's here on the Nano editor you have the shortcuts mentioned here. So write out means save, and to come out Control X. And I'll show you the file now. And I forgot to mention that whether you should follow me or not. So I would say that in the first part, try to see what I'm doing, and we'll get some time for you to do things a little later. So if you have this command, if you execute it on the terminal, it will print, this script is running here, and then the host name would print directly here. But instead of that, we are going to run it via a file. Because do you remember what we should do to make this file executable?
+X.
Yes. So you have to, in the Unix system, you have to mention that this is a file that you should execute. And then I'm going to execute that file. So no scheduler involved, nothing involved. This is how you would do it on a laptop or a desktop that you are directly have access. You type that, and then it'll say that it's printed on, it's running on the login node, the computer. So this is how we do things today. Is that okay, Bukit? Is it understandable?
Yes, quite understandable.
Yes. Then the next step, what we're going to do is try the same thing using the scheduler. For that, if you want to go to a restaurant, you have to pay for your meal. So you need some account to pay for it. Do you remember the command to find out which accounts you have access to, Bukit?
Grab.
Yeah. Also projects. You could type the command projects. Yes. You could type the projects, and this is the project that we'll be using for the course. So you have to pay for it, not with Norwegian krona, fortunately. This with credits. So these accounts will have some credits. So you have to pay for it. First thing you have to find out is your project. And whenever it says projects later on, it has to be replaced with this number. So if you don't see 9970, you could contact the course organizers, Espen or Dania, and you could get access. Otherwise, if you already have a project access, you could use that. And then there's some cheating going on here a little bit, because we have a reservation, which means like we have told the scheduler that we are running a course. So we don't want to wait in the queue to see direct output. So let us go in and perform analysis in a faster way. So that you can use. Let's see if that's needed, we'll use that as well. In addition to that, okay, let's see how we do that. So if you remember how we did run our job without the scheduler, use execute it. To use the scheduler, you should use sbatch, the account that you're going to pay with. So Bukit, I'm going to make some typos. So your job is to detect those typos and tell me which ones are wrong.
Okay, but
then,
before the regular typo, you wrote account
yes,
with double A. It is not a
Okay.
typical typo you did before.
Okay. Okay, so let's see. Yes. So because I mentioned that I'm going to make this do this purposefully, so then I'm not embarrassed anymore. So then you have to inform that how much memory you need. This is hard to get to know if you have first analysis. So there's some trial and error needed. But for the test, we'll say we only need very small amount of RAM, because just we're going to print the some host name. Then you get the example job. So you did here, and there's another typo here. I'm purposefully doing that error, because this is the first error that people do, and a lot of questions come. Before the questions come, it's better that I do it and show the error. Then we are done with it. Do you see the error, Bukit?
Yes, you wrote your bank account numbers.
Yes.
There is a K missing.
Yes. So these are case sensitive, and you have to do it right exactly as it is. So this is the first error. If you are using the HPC system for the first time, you will see a lot of errors like this. But if you read it carefully, it will tell you what to do. Then I will submit it, and then you get a job ID. In the future, when you do perform analysis, and if you get any issues when you're contacting us, it's very important that you send us the job ID, so it's easier for us to check. Then the command to SQ to see where your job is running, because this is a very small job. It might already be finished. SQ minus U. What are the jobs that waiting in the queue? There's nothing, which means it was very fast. And then when the job is finished, there will be some log files created. Bukit, do you remember the command to find out what files are in a folder?
ls
Yes.
minus L.
Yes. So then there's one extra file created by the Slurm manager here. Let's see the content of it. This part, there are so many artifacts, which means that not part of what we are going to do, some details, but our focus is here. So this says that your job was running on C520, which means the 5th rack, the compute node with name with the compute node with the name C5-6. So we managed to send that job to the HPC, what we call the compute cluster instead of running it on a login node.
Sabri, sorry to interrupt. Morten has something to say.
Yes,
can you please move your terminal slightly up, because some people are having issues with it being obscured by the Zoom subtitle thing.
Like this?
Yes, thank you.
Okay. Thank you, Morten. Okay, then I come out of it. So you went on and use the scheduler to do the perform the analysis. So this is how you do it. So in addition to running your job, you have to mention these things. So the customizing the job, which means that we have started a very basic file with to just print where we are running. But typing this all the time could be, it's not convenient. So what we do is we can move this inside this job itself. So let's see how we move that. So Morten, can I keep a track of if I move my terminal again? So you have to let me know that if it get covered. So there are different editors that you could use. So for this course, we are using the Nano editor. Example job. So here, the hash on the top, this has a special meaning. So this means that it's in bash language. And rest of the file, if you have a hash, so which means that this is comment. So if you want to just have a comment for yourself, to see what's going on about what is going on. But with Slurm, if you have a hash and S batch, if something starts with like this, it has a special meaning, which means that instruction will be taken by a Slurm. So you can have a count, as we mentioned in the terminal itself, NN997. Okay, I will make sure that it's the correct
Yeah, correct.
now. Yes. Then you can have the mem 1 GB, and then you can have the time. You could also mix. You can have some of this inside the file. You can specify some of it outside the file. So the order is that if you specify something after dispatch, that takes precedence. It will override whatever we write here. Then we have what else we do? Do we need Bucket?
I think that's enough. Mem, time. Yeah.
And also in this example, they're asking to include the name, so we'll include that as well. To be consistent. Dispatch, so that's the wrong spelling. S-O-L-T-C-H. And it has to be in capitals, Booker, by the way. Just start with the hash, it has to be capitals. And then job name, I would say my, not too long, because if the job name is long, it's very difficult to read it when you check first job, for example. I'll just have it and no spaces, etc. So these things are included. So then I'm going to save the file, exit. and I'm going to print the content of the file just to show you again what's in it. So we have the shebang line, bash, and then all the Slurm instructions. And then we have this, we call this a payload, what's going to happen. And to cover the next section, next example that we're going to show, we're going to show something like, how to use the SQ command to see the status. For this, we need to simulate a slightly bigger job. So let's see how to do that. So before you printing the host name, I'm going to print the date, just to print the time. And I'm going to ask to sleep for 60 seconds. So this simulates an analysis which takes 1 minute. Does that make sense, Bhagat?
Yes, but what about the time limits?
Yes. So we are going 1 minute. So we are going like extremely close. We are asking for 1 minute, and our job supposed to be 1 minute as well. So let's see what happens. I'll show the job again. Just to give an idea about this sleep command. So if you say echo hi, it'll immediately print. If you say sleep for 2 seconds and print echo, then it'll sleep for 2 seconds and print hi afterwards. So it's just a delay, just to simulate that something going on. Then when we, if you remember Bhagat, then if I go with my up arrow key on my keyboard, I'll see that what I've typed before. So this we included inside the file, no need. This we included inside the file, that's also not needed. So now we can directly call with dispatch, because the detail that the Slurm needs is inside the file itself. So we submit that. And then I will ask the SQ, the command, what's going on in the queue, and limit that to my user. Otherwise, it will print everything about all the users that are in the system. And it says it's running for 11 seconds now on the C560 node, and I will iterate it to print it, to check it over and over again. So while this is going on, can you check on the time, Bhagat, how we are doing? Are we okay?
Yeah, we are on time.
Yeah. So now it's been 34 seconds, 39, still going on. And this, you see that this is the job, the name we used. So as I said, if you use a long name, you only the first 8 characters you can see. So it's better to use a shorter descriptive name than a very long name. Now it's 54 seconds. 59. And it should end at some point, but Slurm gives a little bit of time. It doesn't, when you ask for 1 minute, it will run for about 1 minute 20 seconds, 1 minute 30 seconds, probably. So while that is running, so these things, how would you know that, for example, these SBatch commands? So what are the things that could be, what are the valid commands that you could use? For that, you could use.
You should have manuals.
Yes, manual, yes. So now the job has ended. So let's see the, I'm going to sort the files because that I have more than one log file now. So this is the log file that was created for this job. If you remember, my job ID is 786. I have a log file with 786. Let's see what's inside. So it was running, so no harm done. It took 1 minute, and we asked for 1 minute, and then it waited for some time before it's ended. So then what we see is that it's the resources that we asked. We asked for 1 minute. It took 1 minute, so everything is good. But it's not always possible to ask exactly the amount that time we needed. So what we do is we ask slightly more time than we actually need. But look at what happens is, if you ask a lot of time, the queue manager makes you wait longer, because it will try to run the shorter jobs first and then let you in. So that is a compromise that we have to make at the optimal time. That's one of the tricky parts that you have to figure out when you use the HPC system. Did I miss anything here?
Would it be right less amount of time? Would it be right?
Yeah, so we could ask, we'll see what will happen if that happens. So I'm going to remove this the log files now with the remove command we learned yesterday, because I want it clear. So I have this file. Let's do this. I used a different editor. Sorry, because my muscle memory, I'll go back to Nano. So we have here. So it prints the date and it's sleep for, let's say it's sleep for 20 seconds and print the date again and maybe sleep for 2 minutes. But we still ask for 1 minute as the runtime. Let's see what happens. Control O, Control X, again to show you what's inside the file. So the file is like that. We have the shebang line on top, Slurm instructions afterwards, immediately afterwards. It's very important that you don't have anything before the Slurm instructions. Everything should come afterwards. And then we are asking to print something going on here. Let's remove that new line as well. So because then that will be more clearer. I want to print it in a new line, not on the same line. So then what happens is it's going to sleep for a while and going to print a time and it's going to wait. So this simulates that you ask for some time, but let's start it and talk. Dispatch example, and then SQ. So this simulates that you said the queue manager, you mentioned to the queue manager that I need 1 minute, but inside your job, it runs after 1 minute. It takes longer time. So this, so I could, because of that question, maybe I could explain something that we're going to talk a little bit later, which is that resource requests are binding, which means if you ask for 1 MB, 1 GB of RAM, you should not use more than 1 GB of RAM. If you say that you're going to run the job for 1 hour, you should not run it for more than 1 hour. If you do, the Slurm will cancel your job. And if you don't have checkpointing, which means that your job could not start from the place it ended before, then you will lose your work. So it's always safe to ask a little bit more time. So after 59 minutes, it's still running. 59 seconds, it's still running. Let's see what happens. So it gives some grace period. Now it is kind of trying to end. Yeah, 10 seconds. CG means it's like copying back files and consolidating the results, etc. So it's ended at 1 minute as expected. So let's see what the log file says. This says it was running, so it printed the first time at 10:42, and after 20 seconds, it also printed that time as well. After that, when it was waiting for the 120 seconds, it got cancelled. So it says here due to time limit. So that's the good question you ask, because by looking at the log file itself, even without contacting the support, you could figure out what the reason for the failure of the job if you read it closely. If you have more questions about it, please use the shared document to ask more questions. Because what I think is I should also use this Slurm man pages. It's easier to browse because after Mike said yesterday, why don't we just use the browser instead? The terminal. I will just ask here. Slurm dispatch. The official document are in this SHMID website. So you could go here and check what are the allowed options. For example, if you want something specific, rename the log file to something else, ask more resources, etc., etc. You could read from that web page. Also, you could ask man dispatch if you want to ask it on the terminal itself. So this will have the version of it on the terminal. But if you could also use the website if that is more convenient. If you start the man page on the terminal, the way to get out is to press the Q, the key Q on the keyboard, quit. And then I would say that we will go for the exercise booklet now, because it's better to practice a little bit, because I was asking not to follow on because it's better to have a look if you're new for the first time, and try to do this exercise yourself. And then after that, depending on the availability of the time, we will also talk about the details which concerns at the bottom about other types of jobs. But for the time being, this is the exercise. So this is to change the default, that slurm file that created here. You see that it's created slurm something. But if you wanted to give your own name, how would you do that? So shall we give 10 minutes? Bukit, what do you think? Is it enough? 10 minutes?
Yeah, I think it's enough.
Okay, then get started. And in the shared document, we could have a poll to see whether that time is enough. And then after the exercise, we'll talk a little bit more. Yes, now please try to do this exercise. And if you have any issues, try the shared document, and I'll open the shared document here. We'll
We'll be here.
Yeah, we'll be here. So
So how long is it until 10:57, Sabri?
Yes.
Yeah, 10:57, or like if you have a poll and if everybody's done, we can just start.
Okay.
Yeah. So I will just have a look and the questions a little bit until we do that. So please go ahead with the exercise.
But I think before moving on, the question 26 is important for the new beginners, because I also faced the same question in my mind when I first started this HPC stuff, because everything seems going on in login node, but actually nothing is happening on login node. Yes, we are writing the commands on login node, but we are forwarding it to the clusters, not the processes are not going on in login nodes. Maybe you can add important things.
Yes, good point, Bukit. So here, before I forget, I would like to mention that when you start a job, your job, it will print which compute node it's running. So this means that this job is running, there could be more than one compute node. So when you, after submitting, the scheduler or that blue person, the slurm, it will take the job and it will allocate you in a compute node. So if you don't ask for a whole node, so there's also a way to ask whole nodes. In this description, you will see that research request. So if you ask exclusive, let's see. Yeah, let's see whether they have exclusive. Yeah, so if you ask something like this, exclusive one node, which means nobody else will share it, only one node. If you don't use this, and if you ask less than the number of cores that in that machine, you will be sharing with the user. But which machine it runs, it will print here. So another way to get more details is that I will use that to show that command as well. I'm going to submit that job that failed again. Then I'm going to use S control show job. This is there in the material. I check again just to make sure. Show job, this, the job ID. Then this will print a lot of details. Who submitted it, where it is running, the job status, when it was submitted, when it's eligible, when it's about to be reach the compute node, and when it is expected to end, depending on the details that you are given, the name of the compute node, how many CPUs you asked, for example. So you could get these details. But if it is an older job, scontrol might not work. Let's say I will check my queue again, sq minus u $user, because I want to cancel this job. You could use s cancel, because I know that this job will fail because I'm asking more time than I should. I could cancel that job. Then I could, for older jobs, we have the command sarchive, SACCT. For example, if I want my jobs, what are the jobs that I have been submitted for the last period? Then I have a few of these jobs. So if you ask this job let's get that command again, as control, it would say invalid because that's too old. So in that case, you could use archive. Let's say CCT minus job ID. Then it'll give some details about what happened and details. And you could ask the slurm, the man pages. CCT slurm. Then if you read here, it will tell you that if you want more details, you could do something like the output, or then it will give an enormous amount of information that will be printed, all the details, how much memory it reached, how much cores it reached, so whether it used the GPU, that kind of things, how much memory you requested, how much you actually used. So this will be possible. This will be, you could use for the so the evaluation or to modify your later jobs. So the short answer for that question is that when you submit from a login node, the slurms take care of everything else. So you don't worry about where it actually runs. You always negotiate with the queue manager. So you can ask, you have two commands that you can use. One is scontrol. The other one is sarchive to get details about past and current jobs, where it runs, what happens, that kind of thing. Does that
Can we
answer
select? Yes. Can we select nodes, Sabri?
We should, but we shouldn't. There's a possibility to specify nodes. For example, there are some tests people do which are node specific, very sensitive information that for the results are very sensitive. So if you want to reproduce, you have to do the same simulation on the same node. Then you can specify the node itself. It's possible with like we did with accounts and MEM, you could also specify the nodes. But if you specify that, if somebody else is using it, then it will take a long time to get the reservation. So if you are not have a very sensitive specificity to run a simulation on the same node over and over again, don't use try to get a node. Let Slurm decide where it best fits. Dania, did you want to say something?
Yeah, one thing about different nodes, like huge memory nodes. So if you have some computation, you can specify the job types. We have documentation on that. When you are familiar with the Slurm and you have big computation to done, there are different job types that you can use. And one other thing, Sabri, are you going to introduce Ceph?
Introduce?
Ceph?
No, not
Okay.
in this lesson. No.
Okay.
So in the S-info lesson, you will see this big mem. So if you have a job that running, so although I said don't specify the node itself, but you can tell what kind of job it is. You could specify partition, for example. If you want to run it on big memory node, when you submit your job, when did I submit my job? Yes, here you could say partition equals big mem, so you'll make sure that it ends up in memory with the node with the big number, as Dania said. So here you could find more details about if you search for slurm big mem, let me find, but you can also link it from the site itself. We have type of jobs here, which would described. So if you could, I could paste this on the shared document.
I already pasted it in question 26.
Thank you, Tanya. Yes, okay. So you could get that information. So now, Buket, so what I'm going to show is there's another kind of jobs, interactive jobs. Let's say you are not still ready to pack everything into a file and then send it. You want some interaction. You want to test some things. For this, we have, if I go further down, interactive jobs. This is like you go to call the restaurant and you'll say, I want a table for the day. I'll come and go as I wish. So that's very expensive. And it's also wastage of resources. So what you're going to do is you're going to book some resources, but you're not going to perform analysis continuously. That's why it's not that encouraging for HPC system, but that's also possible. I will clear the screen, prepare myself. And here, the way to get that is with salloc command. Instead of sbatch, we use salloc command. And I will also use this cheat here that I mentioned before. I need to copy the exact wording of that. So I'm scrolling up. I'm sorry about scrolling up again. I'll just copy something and I'll come back. Yes. So I'm going to use this cheat. So I'll not, because I'm going to ask something for slightly longer. It might take longer to get the resources. I'm scrolling back down again, which I would have, should have avoided. So here, what you do is, let me get some space. I'm asking that for half an hour, I want a table. I want to come and go as I wish. First the host name to show that it's a login node. If you remember, Morten was showing you like SSH before. So this is another way to, let me paste that what I type. So I don't miss the spellings of that reservation. So I'm going to use this reservation for this. And then I will ask for 10 minutes of interactivity. And here, when you mention time, you mention minutes like this, sorry, seconds, and then minutes. These are seconds, and we have 10 minutes mentioned here. And if you want 2 hours, you would mention like this, but you could also mention in days with a dash. So this means that 2 days, 2 hours, and 10 minutes. So for this time, I'm going to only ask 10 minutes. And then I want one core for this. Is task 1 and memory of 4 GB. So on different clusters, there might be different requirements. So this, for our HPC system, we have, you should mention the memory at least. So then you, okay. Here, I see that there's an error. Let me see whether I can clear allocation. Okay, so requested node specification is not valid. Count. Check for the spellings, accounts. Okay.
I think it is not partition, it is reservation.
Okay.
Because we use partition in from.
Okay, so reservation. Okay, there's a invalid character. This is what happens when you copy paste. I'm going to type now.
Okay, let me check.
Alloc count equals 997. Okay. Reservation. After I submit this, I will show you, how to find this if you don't know this reservation, for example. And then I'm going to specify the time equals 10 minutes, and in tasks 1 and mem equals 1 GB. Now it's going on. So this one here, this means that you see this error when I type. When I copy paste it from the web page, it pasted some weird character. So now I am logged in. I can ask host name. So I'm in a compute node now. So if you want to compile something on a compute node or test something on a compute node without bothering people on the login node, you could reserve this. But you should be aware that while you are here, now I'm waiting. I'm not doing anything, which means that compute node is consuming electricity, reserving resources, but nothing is going on. So it's better that you don't book it for a long time, but to your test, you book it and then you release it. So the queue manager, when you submit, when you pack everything in a file and give it to the queue manager to arrange everything for you, that's better because that's better resource management. If you must, it's also okay to use the interactive node for some tests. But when you are using this, if you lose your internet connection, then this will be disconnected. For that, you have to use some specific tools on your laptop side, not on the server side. Those tools are mentioned later on this lesson as well. Let's see. Yeah, so we have some time now. So that's two MOOCs and screen, two more softwares that you can do. So here I'm going to exit. So the jobs will be released for others to use. So anything else that we could discuss in this lesson? Let's see if I missed something.
We didn't mention about canceling job, did we?
I showed it, but I can show that again. So let's see if I have a job running.
Yeah, as cancel. Yeah.
I will submit that is batch job, example job, and I realized that that's the wrong job. I had changed something. Then you could say let's cancel and the job ID, and it will be cancelled. Then your SQ would show this. It's being ended. There are a few other commands that are very specific for our HPC systems, like the one we saw already, the projects command, and another command that help you to kind of understand the current resource usage of the entire system is Bucket. You have a command called freep. So this command will print, freep is the command, the status of all the compute nodes. So for example, if you take C140, half of it is 20 of the 40 cores are being used and most of the memory is used. So it's in a mixed mode, which means that will be shared with, it could be shared. And this idle, so we have C71, out of all the 24 cores are free, which means if you submit a job, it's highly likely that you get that. And then, yeah, you could get information like that. So the freep is a command that's specific to us, and the projects is a command that's specific to us as well. And there's another command which is the usage, which you'll learn a little later. Let's see any other questions here that needs attention. Anything else that you see, Buket, that we should address more?
I'm also looking at the questions.
So the job ID bucket, sometimes you get requeued, which means that for your job, the job ID is fixed. But sometimes the job that you are, the compute node that our job is running, it might fail. Then it might get new job IDs. There's a possibility, but that's yeah, usually you should say that when you get a job ID, it's okay to say that is the job ID that you're going to have for the rest of the analysis. You could use with the SQ to make sure that. So our colleagues on NRIS, maybe Espen, could you check please if it gets requeued, you get a new job ID, or maybe it is the same thing that same job ID you'll get. But there could be part of jobs, one job, some jobs, they have multiple parts, so they will get subversion, like instead of let's see, the job ID we got for this was this 11310028, but there could be 0028.1, 0.2, and 0.3. But yeah, for this question, I think it's important that we have to check whether the job ID changes if it's requeued, and we could answer that there. Yeah, so if you underestimate the time, if it's a like rare case, and you have done a lot of analysis, and you don't want to lose the job, you could send a request to the support team. My job is going to end in another 6 hours or maybe 24 hours. Can you please extend it? So the users, or like when I am a user, I can't extend my job, but the admin staff, they could give little more, extend the job time. If you ask for 24 hours or like 6 days, they could add another 6 hours for it. Yes, knowing the amount of memory is little tricky. That comes with experience and then your trial and error. Yeah, so this is basic unique stuff. When you are editing a file in a text editor, there are challenges. Yes, finish job. Yes, the username. This username should be replaced with your username, or use capital $user if you want that. Yes, so then because we have another 17, yeah,
13 minutes, Sabri.
about 30 minutes. So what I'll do is, Bukat, I will try to run another job. For this, what I will do is, let's see whether we have any special kind of jobs that we could use here. I'm going to, maybe we can try a Python job, for example, just to see how that will work. Test.
Before that, will you comment anything about Tmax?
No, that is I'm not going to comment much about it, because it's a very if you know Tmax, it'll make sense, but Tmax is not something we could teach in half an hour. It takes some time, and there are alternatives like Screen people already use. So the Tmax is mentioned here because if you lose your internet connection, then you will lose the interactive session. But it is best that you ask for time in your interaction session not too long, so you don't, it doesn't break. So the advice is that if you have a very long interactive session, that you should start from a Tmax session or a Screen session. That's from your laptop side. So that's nothing to in the HPC side. So let's see. So let's see something print. from Python, just to give an idea on how this works. Okay, I used the nano editor, did I? Yes, Control O, Control X. So if you have Python, so tomorrow when you load modules, when you learn about software, you'll learn more things. So this just print Python. So if you want this script to be inside the example job, I will remove these things. A real example of this, right? A real payload. You would have that here. So as you see that, that file is started, it's called from the job file. Then we can save it. I'll show that file again, what the content. So we have the shebang, and the slurm instructions. And then this is how you call your Python program. I'll remove the slurm log files here, and then s batch. You don't call the test py, you call the job script. So the job script calls the Python file. So that is the different here. Yes, so that's all I want to mention. So if you have more questions, please go and ask here so we can discuss more things. Otherwise, you can go for a longer break and then come back. Or maybe you could also try, just try the scripts, and we'll be here. So if you want to try more things.
So what do you suggest, Sabri? We go for a break or try things for 10 minutes?
Yeah, so no, so the scheduled break is at 11:30. So we have 9 minutes. So I'll recommend that we wait here 9 minutes.
Yes.
So we'll be around, ask questions, try the scripts.
And then we'll go for break at 11:30.
11:30, yes.
Yes, thank you. Welcome back. I hope you had a good break. And now we will go ahead with the next session, which is transferring files. Morten will lead the discussion and I will follow along. Okay.
Okay, thank you, Danya. So, as it says here, if we want to do useful things with HPC, run simulations, get interesting results, we really need to be able to transfer data to and from the cluster. So in a sense, we have already done this. We have transferred some data from the terminal, which we can see, to our brains, but we need to be able to do this in a more large-scale way. So maybe, Danya, do you have an example of some files that could be useful to transfer from your laptop to the HPC cluster? What is a typical workflow?
Oh, if I want to transfer from my laptop, I use one of these tools, rsync or SCP, as
Yeah, sorry,
mentioned, or the internet.
Sorry, I meant what kind of files would you want to transfer?
Oh, mostly it is my codes, which I want to scale it up to the HPC. And the data files. Most of my data files are in internet, so I usually use the wget script a lot to download data sets. But the code which are developing on my own laptop, that's what I need mostly to upload on the HPC when I want to work. And after I did the simulation, I need the process data on my laptop. So I do these things together.
Okay,
and what about you?
Yeah, it's the same for us. Mostly, we also have the code that we developed. We developed code locally, but then we store it online on GitHub usually. So then, when we need it on the cluster, we download it from the internet. So it goes from my laptop, I upload it to the internet, and then I download it on the cluster. And then usually we need to transfer input files for simulations to the cluster, and then output files back from the cluster to the laptop to be able to work with them. So if we just start off maybe with the simple operation of downloading from the internet. So first of all, you see I have 2 terminals up here. So I have one that is locally on my laptop down here. So this is sitting in my home area on my laptop. And then I have one up here logged into Saga, sitting now in my home folder on Saga. And underneath here, you can see the short history. So the last 3 commands for each of the terminals. So Björn, I think yesterday morning, showed you how you can download things from the internet with wget. I think it's more useful for this session, which you can choose to follow along with what I'm doing, or you can just observe. Either way is fine for this session.
Yeah, we are not having any exercise for this session. It's mostly on demo, right?
Yes, but you can choose to follow along the same steps that I'm doing, or you can just observe. But I think it's useful for later on to try this git command. So GitHub and GitLab, they are repositories for code and for version control. They're very often used, so it's useful to have seen this. On Saga, Git will be installed. On your laptop, probably also Git will be installed, or you will have to install it. But for now, we can use this git clone command to download some code from this test repository.
Are you using Git clone a lot, Morten?
Yes, this is really bread and butter. This I use every single day. So this is a very useful command. So git clone, if we just copy paste it into the terminal, notice I'm on Saga, so I'm doing this on Saga. Git clone will download the code that is in this URL. And by default, it will be named the same thing as the code in the URL. So now it will be called Hello World. If we press enter, it will hopefully, yes. So it says cloning into Hello World. So now we can, as we learned yesterday, ls-lh to look at what is in our home folder. We can also add tr, and then we get the latest additions at the bottom. So we see here we have a folder called Hello World. For now, we can go into it and look at it. What it contains doesn't really matter that much. There are some files, but we will use them later.
This is very useful when you want to have some codes, especially which is published on GitLab public repository or your project repository. You can use this command.
Yes. So as Daniel mentioned very briefly earlier on in the session, there are multiple ways of transferring files. So you have notably SCP and rsync, which are covered by this tutorial. For what I'm talking about right now, I'm using SCP just because it's more widely available. So every one of you should have SCP available, so you can follow along.
The SCP is a default on Windows system as well if you have SSH. rsync is available on Linux and Mac, but Windows you need to use it with Linux, Windows subsystem for Linux. So that's why, because SCP is default, we are demoing this here during the course. For best practices, our documentation says, or we recommend rsync. But the default, the baseline is similar for SCP and rsync, the path and things, right, Morten?
Yes, so we recommend rsync because there are some it has some benefits, especially if you deal with very large files or a large amount of files. So transferring a lot of data back and forth, it will be more useful to use rsync. But for basic usage, whichever one you use doesn't really matter that much. So for now, we will use SCP. So let's try to do this example right here. So now I hop into my terminal locally on my laptop. So down here. So let's make a file. Mike and another one taught you about how to make files yesterday with this greater than symbol. So let's make a file called from laptop.txt. So with one of the greater than symbols, this will create the file. If this file already existed, it would delete whatever was in it and replace it with this date. So this will print the date to this file. So let's hit enter. We can use cat to look at it from laptop. So this will just print the contents of this file. And it says Wednesday, April 10th, it is 10:53. Now we can also, if we want to add more things to this file, let's add host name. This is the command we used earlier on Saga to see which login nodes we were in. We can also use it locally on this machine. Two greater than signs means append to the file that already exists. So from laptop. And now it should have another line. So let's inspect it, cat from laptop. And it will show the date as before, and then a new line with the address of my laptop. Okay, great. So now let's try to move this file from, notice I'm in my home directory on my laptop. Let's move it here and copy it to the home directory on Saga. So what we do is we use the scp command. We tell it which file we want to move. So it's the from laptop. And then if we want to move it to Saga, we need to tell it the username, the address. And then we need to say where should we put it. So there needs to be a colon and then a path to wherever we want to put it. If we give no path, it will just default to the home directory. And if we give it no, and it will also just default to having the same name as the file we are copying from. So let's hit enter. It will ask for your password. Let's hope I can actually type my password correctly. Yes. It says this was very fast, but if you have quick eyes, you saw that there is a progress indicator. Very fast, went up to 100% and transfer the file over. So then let's hop into the terminal on Saga. We can use ls and then add the tr to the end so that we get the newest file first. And we'll see here we have the file transferred. So just for completeness, let's inspect it here also and see that we get this was made at 11:54 from my local laptop. Okay, great. Now let's try to go the other way. So I will now in my terminal on Saga, let's make a new file and put, first of all, we can put the date in and say from cluster.txt. So this creates the file. Let's inspect the file. We see the date is, the time is now 11:57. Let's also put the host name in there. Now notice with the double greater than signs. And once again, we can inspect the file from cluster, and we see it has been made on the third login node on Saga. So now going back to my local laptop terminal, let's download this from cluster file.
Before that,
to-
can you ls list what is in your laptop directory, just to see?
It will be a lot of things.
Yeah.
So we have the
Yeah.
from laptop file, we can make it, no, actually like this, sorry. So sorted in the way like before. So we have the most recently edited file in the last. So this has the from laptop txt file. But let's now download the from cluster file to the laptop. So we reverse the order from before. So we do SEP, and then now the first command is the source of what we want to copy. So now we want to copy from the cluster. We have to do name, so the address for Saga, colon, and then from cluster. So this is the file name on Saga. If you want to, you can add, so this is cluster home, and then my user. So this is technically the full path of the file. But if we don't specify the full path, it will just assume that we are copying from the home folder, which in this case is what we're doing. So we don't have to specify this.
Yeah, I would say that placing the path is best practices, because if you have some directory and the files are under that directory, it would always nice to specify the path. Or
Yes.
how do you?
So
Yeah.
Yes, I agree. So let's do it like this first, and then we can we can change it in the next step. So here, if we want to just copy it to wherever we are, remember I am in the home folder on my laptop. We can just place a dot, and it will copy it to wherever we are with the same name of the file. So let's hit enter. Type our password. I put that correctly. Okay, so it says 100% downloaded.
Yeah.
Let's now inspect.
Yes, to command yet you have to put your right password, otherwise it will show permission denied.
Yeah,
message.
yes. So if you type your password incorrectly, like I do, because I'm not used to typing it, it will tell you permission denied. So let's look at it now, ls, and then do the tr. So it's sorted in the reverse order with the most recently edited file first. So let's look at it. We see now on my laptop, I have the from cluster txt file. So let's just, for completeness, inspect it with cat and see it contains the date 11:57, and it was made on the login node on Saga. Okay, but now as Daniel said, let's go to the terminal on Saga. Let's move this file into a different folder. Let's make a folder called tests and enter the test folder. Let's move the file. So mv moves the file. Do from cluster. And then the target for the move. So we move it from one step up in the file hierarchy. So that's the previous folder. We move it into this folder. So now print working directory pvd. I am in cluster home, my username. So this is my home folder, and inside my home folder, I'm in the test folder. And currently in this test folder, there is one file, and it's called from cluster. So now maybe to differentiate this, let's maybe rename it and call it from cluster 2. And also maybe let's add timestamp again. So echo double greater than sign, so append to the file from cluster 2. This, it's not called time, it's called dates. Sorry. And now let's inspect the new file from cluster 2. And we see we have this is the contents of the old file, and now we have appended a new line with the time 12:03. Okay, so now going back to my laptop, let's copy this, let's download this file to my laptop from the cluster. So like before, we do SCP. The source where we are trying to download from is on Saga. So I put in my username, the address of Saga, colon, and now I need to actually specify the path of the file. So if we do print working directory on Saga, remember we are in cluster home, my username, test, and then inside here is the file called from cluster to txt. And once again, I just want to download it to the directory I am in on my laptop, which is my home folder on my laptop. So we just put the dot, we hit enter, and we put in the password. Put in the password correctly. And now we see we can do ls with a -tr to get the most recent file changed first. And we see we have a new file created just now called from cluster 2, which was just downloaded. So let's just for completeness inspect it, and we see this is the new file that was downloaded. So this is what you would most often do with the SCP command. So SCP, your username, the address of Saga, and then you put in the full path of the file that you want to download. You have any comments on this, Daniel, or is it clear?
It's very clear, and you will demo about downloading or transferring directories or many files, right?
Yes. So we can do now the reason, or some of the reason why I downloaded this GitHub repository earlier was so that we have some repository that we can try to transfer. So let's go away from this test directory. We go to the home directory on Saga. Let's inspect the files. So remember, we have this hello world directory. If we go into it, it has some files. It also has some hidden files. If you use the -a, you see the hidden files. So there are some hidden files, also a hidden directory in here. So let's try to download this whole directory to our laptop. So what we do, we use the same command, SCP, the source we are trying to download from. So my username, Saga, the address. And then the directory is called hello world. And then if I want to download this to right where I am now in the home directory on my laptop, I just put a dot. So what will happen if I do this now, Danya, and just hit enter?
Because you are downloading a directory, you need to specify that you are downloading directory. It will say it's. I'm not sure what would be the error message, but it won't work.
Let's see what it will say actually. Okay, first of all, I have to learn how to type in my password. This is the hardest part of, okay, once again, I'm sorry. Is something going on with my keyboard? Okay, finally I managed to type my password. So it says the error message, it says SCP hello world, not a regular file, which is correct. It is a repository, it is a directory. So what we need to add is the -r to tell the SCP command that we want to do this recursively. So whatever is in the directory, we want to download the whole directory and any subdirectories. So let's try this now. So here we see a bunch of things were downloaded. SCP shows us by default every single file. So these are the contents of this directory doesn't really matter. It's just as an example. But let's look at it. So we can go into, let's do the ls with the tr again. We see we have this hello world directory. We can go into it. It has some contents, the same way as on Saga. It also has some hidden content. So any comments on this, Daniel? Or is it...
No, I don't see any question here. No comments. Just that when you use SCP-R option, and that the whole directory and all the contents inside the directory will be copied, and you can search man SCP for different options, or you can use web browser like Sabri and Mike showed you earlier today and yesterday. There are many options you can use with SCP, and if you prefer, you can use rsync. But the basic principle of putting specifying the path are same in SCP and rsync.
Yes, exactly. So the usage is more or less the same. You can read in the tutorial page about how to use rsync as well. There are tabs which you can click to get the corresponding exactly the same commands just for rsync. So as Dania mentioned, as Dania mentioned earlier, actually at NRIS we suggest for best practices that you use rsync, and there are two points, two reasons why you should use rsync over SCP. And one of them is if you are transferring very large files, rsync supports this partial flag, which will split the file into small pieces and download them individually. And then if the download fails, Imagine you have a file that takes 1 hour to download from Saga to your laptop. If you use SCP and the download fails, maybe you lose your internet connection after 50 minutes, you have to redo the whole thing. You have to wait another 1 hour. Whereas with rsync, you can use the partial flag, and it will remember the parts of the file that was already downloaded. So if you lose connection after 50 minutes, you only have to wait another 10 minutes for the rest of the file to download. Also, if you are downloading or uploading a very large amount of files, rsync handles this faster and better than SCP. So
Yeah, that's a good thing that ICP can compress it and with the options, of course.
yes. So how are we on time?
Yes, we have 1 minute, but you can mention about VS Code that we have some
Yes.
documentation on that.
Yeah, we have some documentation. I will take 30 seconds to just.
Yeah,
show
that's
you.
fine. Yeah, we
I
have.
have set up. So this is Visual Studio Code. I guess many of you use it. If you don't use it, you can. It's a text editor. I use it every day locally on my laptop. And you can connect it with an extension called SSH Remote. You can use this extension in VS Code to connect it to the Sigma 2 machines. So this is what I've done here. This is a program. This is a text editor now running on my laptop, connected to my home area on Saga. So these are the files in my home directory on Saga. So let's see if we can find the, yeah, here is the test directory that we just created earlier, and we can look at the file. So here is, remember the file that we manually downloaded using SCP earlier. We can now inspect directly in my text editor, now running locally on my machine. And we can also do simple file transfer operations. Like for example, on my Mac, I can go to my Finder. I can take a random file and I can just drag and drop it into the VS Code window, and it will automatically transfer the file to, I'm not sure where it ended up, sorry. To my home area on Saga. So this is just a random file containing, it doesn't matter, something. I just dragged it across into the VS Code window. And if we go to the terminal, we can see, let's go to the home directory. We do one final time, the ls with the tr. We see here it is in my home folder on Saga. So this is, in a sense, an easier way to transfer files. If you're just transferring one file or a few files, you can just drag and drop them into the VS Code window. So this is, if you want to set this up, this is explained in this page on the documentation. So you can go to this and check it out if you want.
Yeah, and below that page, if you go down, Morten, we have some more information about files generated in different environments. And below, there are some useful links, information that might be useful when you are transferring files that is linked to our documentation about ports and backup, and also about file transfer from NERD, which is our storage cluster.
Yes, thank you.
Yeah, thank you so much, Morten. It was a good session.
Yeah, so I think for this working with the generated files in different environments, I will not say anything about this. You can read this. You can read this yourself. It will be useful for some
So if I don't see specific question regarding file transfer that are not answered, could you share that collaborative document, Martin? Or
Yes.
I think that's for today, but we will keep, if you, I will ask for your feedback for today. One good thing about today, and one thing or many things we should improve for the next day and as well as upcoming event. Regarding file transfer, the best practices are sync. We have a best practices session in May with rsync and data storage. If you would like to, you can join. That would be, you can find that course page on the event page that is linked to this collaborative documents on top of the page. Yeah, please give us feedback. These feedbacks are very valuable for us to improve things in the future and as well as tomorrow. Anything else you want to mention, Morten?
No, I don't think so. Maybe we should let people go for lunch.
Yes, we could do that. And I thank you so much, Morten, and all other instructors who were doing a very good job today. And thank you all participants for their participation and a very interactive, collaborative document session. And we really like to answer the questions and the collaborative document. And I hope that you will continue this trend tomorrow. More question, more is super fun. And this, as I mentioned earlier, this will be shared with you all, as well as it will be publicly available for anyone to look into this. Yeah, that's all. And I will see you tomorrow for the final day. And you will see, you will learn more about accessing software on HPC quota, computer and quota, and how to ask for help and how to use the resources responsibly. These are the 4 sessions we will have tomorrow. Thank you so much. You can stay here. I will stop recording. And if you want to voice out some questions, you are welcome to do that. And I will close the Zoom room only at 12:30. That's our time to close the event.